So we've introduced three basic SI units that describe length and time and mass, but then we just kind of build on those. We kind of combine them in different ways to invent new units. So for an example, like we were to find the area of a rectangle, we could do length times width of the rectangle and find that area. So its units have to have units of length times length. So meters times meters. So our units for area is actually going to be meters squared in SI. I'm like sure you could have centimeters squared, but in SI it would be meters squared. As an example real quick, a piece of cardboard has a length of 0.3 meters by 0.2 meters. What is its area? Area is length times width, so you multiply them together. And so you do the 0.3 times the 0.2, and you get your 0.06. But you also have to multiply the units. So meters times meters, right? But a meter times a meter could also be written as a meter squared. For volume, if you wanted to find the volume of a cube, you'd have to do length times width times height. But then for units, you'd have meters times meters times meters. So our SI unit for volume is going to be meters cubed. So speed describes how far you go in a certain amount of time. And so it has to have units of length over units of time. In SI, that would be meters per second. And you could abbreviate it as m divided by s. And density describes how much mass is in a certain amount of volume. So it'll have units of mass divided by units of volume, and that would be then kilograms divided by meters cubed in SI. Right, this is just the fast introduction. We'll do some practice with this in a bit. Right. The abbreviation of density is going to be this kind of curly looking P thing, and that's the Greek letter rho. And you can also abbreviate mass and volume as a lowercase m for mass and a capital V for volume. Now note that M looks like the abbreviation for meters as well. So you just need to use context to tell them apart. If the little m is being used as a label on a number, it's a unit. It's standing for meters. But if the m is in an equation and you're supposed to plug in a value for it, it's going to be standing for mass, and you're going to plug in a mass for it, like 3 kilograms. So what we can do is take then the idea that density is equal to mass per unit volume, and then just abbreviate it. All this is an abbreviation. And in SI units, you would plug in your mass in kilograms. You would plug in your volume in meters cubed. And then your density would be in kilograms per meter cubed. That would all be SI. Just as a reference point, the density of water is 1,000 kilograms per meters cubed. So anything that has a density less than that would float, and anything that has a density more than that would sink. Right? And just so you know, the density of air is about 1.2. So that's why air floats on top of water. It is much less dense. As an example, let's say an object has a mass of 100 grams and a volume of 30 centimeters cubed. What is its density? So I put rho, density, is equal to mass divided by volume. And for mass, I plugged in the 100 grams. And for volume, I plugged in 30 centimeters cubed. And then you divide the numbers in your calculator. So you do 100 divided by 30, and I got 3.3. But then you also have to divide the units. So I ended up with grams divided by centimeters cubed. Now, grams per centimeters cubed isn't in SI, but at least it still has units of mass divided by length cubed. And in a second, we'll go over unit conversions, so then we would be able to actually convert it to SI if we wanted to. Let's introduce another derived unit for force. Now, forces are just pushes and pulls. So our SI unit of force is a little bit more complicated. It's going to be described as 1 kilogram times a meter divided by a second squared. And abbreviated, that would look like this: kilogram times meter divided by second squared. But writing all of that many, many times can be a pain, so we abbreviate it. Right, so what we're going to do is just kind of bundle it up, repackage it, and call it a Newton. But it's really just a redundant way of saying it. So you could say kilogram times meter divided by second squared, or you could just say Newton. And instead of even writing out the word Newton, you could just write capital N. So how much force is there? 5 newtons. So a conversion factor describes how two units of the same type are related. And so my example that I want to use right now is 1 pound is equal to 4.45 newtons. And that's something you can get out of a table of conversion factors. I usually just go to the front and back covers of a textbook to get them. And a conversion factor is just a weird way of saying that, basically of saying 1 equals 1. Because aren't these just different ways of saying the same amount of force? But here we're using pounds to measure it, and here we're using newtons. So by using algebra, you can rearrange that conversion factor in a couple of different ways. So here's the original way. 1 pound is equal to 4.45 newtons. But what if I divided both sides by the 4.45 newtons? I would end up with this. 1 pound divided by 4.45 newtons is equal to 1. Or I could go back to this and divide both sides by 1 pound. And then I would end up with this. 1 is equal to 4.45 newtons divided by 1 pound. So you can just rearrange a conversion factor in these different ways. And then if you have to use the conversion factor, you pick whichever way looks the most useful. I have now decided to never use the iPad to take my lecture notes again, because I don't know where these page breaks are going to happen. Sorry about that again. So, as an example, if a person has a weight of 180 pounds, what is their weight in newtons? So I'm just going to write down the 180 pounds that we start with, and then I'm going to multiply it by a conversion factor. And so I'm going to grab one of the previous conversion factors up here, and you have to choose which one you want. All right, so since I have pounds here, I want my conversion factor to have pounds in the denominator in the bottom here, so that way I can cancel out and then pounds will just go away. So I chose this one then. All right, so you write that in here. 180 pounds times a conversion factor, 4.45 newtons divided by 1 pound. And then you just do the math on a calculator, 180 times 4.45 divided by 1. But you also have to do the math for the units. So you end up with pounds times a newton divided by pounds. And the pounds cancels out. So we end up with 801 newtons. And soon we'll talk about sig figs for rounding that.